Hello students, I am Nilanjana Sanyal. Welcome you all to my channel in this online math classes. Our today's topic is solving simultaneous equations containing algebraic and logarithmic equations with extraneous solution. We have to solve simultaneous equations in our today's session. That means we will be having two variables, at least two variables. We will be having x and y, two variables, and we will be having two questions in our today's session. The first question will be having, since it will be a set of simultaneous equations, of course, and there will be two variables, we will be given two equations. For the first question, there will be an algebraic equation and a logarithmic equation. And for the second question, there will be two logarithmic equations which will be having extraneous solutions. Okay. So, students, definitely I'll be asking you to stay tuned till the end so that you understand how to solve simultaneous equations which contain logarithmic equation. Okay. So, without any further delay, let us start with our today's session. Let us first of all look at the very first question of our today's session. Question 1. Solve for x and y. Xy is equal to 64. This is the algebraic equation. And log of y to the base x is equal to 2. This is the logarithmic equation. You can start with any of these two equations. If you start with the algebraic one, since the base is x, you can express x in terms of y or y in terms of x. If you express x in terms of y, then x will be equal to 64 over y, and you will be having 64 over y as the base. If you like that, fair enough. You can go for it, and it will definitely be giving you the correct answer. Okay, it's not that you will be coming up with some incorrect answer if you just substitute 64 over y in place of x in the base position. But, or you can substitute, you can take y equal to 64 over x and have this as the argument. In place of y, you can write 64 over x as the argument. That can also be done. Okay. And then you can, since 64 over x, it is in a fractional form, you can separate them. It will be log of 64 to the base x minus log of x to the base x is equal to 2, and log of x to the base x will be equal to 1. You can in fact solve logarithmic equations in multiple ways almost every time. Okay. Not for very trivial ones, but for a fairly I won't say complicated ones, but yeah, average ones. You have more than one way of solving a logarithmic equation. Okay. So, and we have solved so many logarithmic equations till now. I think what I am saying is understandable, makes sense. You are being able to follow whatever I am saying. Like I have said, y equals, if you take y equals 64 over x, you substitute 64 over x in place of y in this logarithmic equation, and you will be having log of 64 over x to the base x equal to 2. And using the quotient rule of logarithms, you can separate the terms. The first term will be log of 64 to the base x minus log of x to the base x equal to 2. And log of x to the base x is equal to 1. So it will be log of 64 to the base x equal to 2 plus 1, which is equal to 3. So log of 64 to the base x is equal to 3. And if you convert it to an exponential equation, it will be 64 equal to x to the power of 3. Okay. And 64 can be written as 4 to the power of 3. So it will be 4 to the power of 3 equal to x to the power of 3. The powers are the same, so we can equate the bases. It will be x equals 4. So we can get the value of x as 4 that way as well. But I have not done it in the way that I have said just now. The first equation that I have taken is the logarithmic one. But you can, of course, as I have said, you can of course take the algebraic one as your starting equation as well. Okay. I have taken the logarithmic equation as my starting equation. And then I have converted this to an exponential equation, and I am getting y equals x square, and I have numbered this equation as equation number 1. Okay. Next, I take up the algebraic equation x times y is equal to 64, and I substitute x square in place of y. So the equation becomes x times x to the power of 2 equal to 64, that is x cubed or x to the power of 3 equal to 64, and 64 equal to 4 to the power of 3. You are getting exactly this form. The thing that I have just now mentioned, if you start with the algebraic one and you substitute in place of y, you write 64 over x, you come to this exact equation, x to the power of 3 equal to 4 to the power of 3. And since the powers are the same, you can equate the bases and it will be x equal to 4. Okay. So x equal to 4, we have got the numerical value of x. What about y? Y is equal to x square from equation number 1. So it is 4 square or y equal to 16. Okay. Now you can check, because these two are positive numbers, you don't have to actually check whether you can take these values or not. If you get a value of 1 or 0 or negative number, then you have, and there is a logarithmic equation in a set of equations that are given to us, then you have to check whether you can take the values or not. Check the values of x and y in case you are having multiple values. Okay. For extraneous solution, you have to always check whenever you are having a logarithmic equation. Okay. So x equal to 4 and y equal to 16 is the answer for our first question. Coming to the second question. Solve for x and y. And over here in this question, we are having two logarithmic equations given. First one is log of x plus y to the base 4 equal to log 2 times log of x to the base 4. And the second one is log of y to the base 4 equal to log of 3 to the base 4 plus log of x to the base 4. The base is the same for both the equations. And in a single equation also, the base is the same for every term. That is a good point. Otherwise, we would have had to, first of all, make the base the same. Okay. So you can start with any of these two given logarithmic equations. I'll be starting with the very first one. So the first one is log of x plus y to the base 4 equal to 2 times log of x to the base 4. And as we have seen before, whenever we have a coefficient of a logarithmic term not equal to 1, we take that in 95% at least or 98% of the times, we always take the coefficient and make it the power of the argument. So that is the thing that we will be doing over here as well. And it becomes log of x to the power of 2 to the base 4. And now we are having log to the base 4 and log to the base 4 on both the sides of the equal to sign. So we can equate the arguments and we get the equation as x plus y equal to x to the power of 2. This is our known form. We are not having this log part anymore. This is our known form. Okay. And you can get another equation from this equation as well by combining these two terms, because the base is the same. It will be log of 3 times x to the base 4, and this is log to the base 4, so you will be having y equals 3x from this equation. And over here it is y equals x square minus x from this equation, and from this equation you will be having y equal to 3x. And then you can solve, but that is one of the ways. Okay. So it is totally up to you. When your concept is clear, you are free to do anything as far as your working is correct, and you get to find the numerical values. You are free to use any method of your choice. Okay, so for this I'm writing y equals x squared minus x. This is my equation number 1. Again, so log of y to the base 4 equal to log of 3 to the base 4 plus log of x to the base 4, and this is log of 3x to the base 4 as I had said before, and this is y equals 3x. Next, I'll be substituting this x squared minus x over here. It will be x squared minus x equal to 3x, equating the right hand sides of equations 1 and 2. We get x squared minus x is equal to 3x. And now this is our well-known quadratic equation, and we know how to solve a quadratic equation. On adding negative 3x to both the sides, we get x squared minus x minus 3x equal to 0, or x squared minus 4x is equal to 0. We can take x as the common factor between these two terms, so it will be x times x minus 4 equal to 0, which gives us the values of x as either equal to 0 or equal to 4. Okay? Because, and can we take both the values, x equal to 0 and x equals 4? We cannot take x equal to 0 because you see x over here log of x to the base 4, even in this question, in this equation log of x to the base 4. X is the argument and we cannot have a 0 argument for a logarithmic term. So we cannot take this x equals 0. We have to take x equals 4. Okay? So this is the extraneous solution. This is what I was saying. Always whenever you solve a logarithmic equation and you are having multiple solutions, you have to check whether you can take both the solutions. It's not that always you have to reject one of them, but you may have to reject one of them. Okay? So we will be taking x equal to 4. So we will be substituting only this value of x equal to 4 in our either equation number 1 or equation number 2 to get the value of y. Okay, so I have chosen equation number 2. You can take equation number 1 as well. I think no one will be taking this equation number 1 but it's very easy. 4 square is 16, 16 minus 4 is 12. It's not a difficult calculation. So if we choose equation number 2, it becomes y equals 3 times 4, which is equal to 12. So our answers are x equals 4 and y equals 12. Okay. So these are the values of x and y for our question number 2. So students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.